Hi, we're starting chapter 9. The title of this chapter is Geometry. So we're not doing the first two sections, 9.1 and 9.2. We're not going to do those. We're going to start with section 9.3, perimeter and area. And I'm sure you have seen most of these formulas before. It's basic geometry, like the perimeter and the area of a rectangle, a triangle, a circle, and so on. So I'm going to read a couple of definitions from the previous two sections. On page 458. Okay, so from the first section, I'm just going to give you a definition of a polygon. So a plane figure is closed if we can draw it without lifting the pencil and if the starting and ending points are the same. So a plane figure is simple if we can draw it without lifting the pencil, and in drawing it, we never pass through the same point twice, with the possible exception of the starting and ending points. Like we can see the first figure is closed and simple. The second one is simple, but it's not closed. The third one is closed, but it's not simple because you pass through the same point. You pass through the same point once or twice. I should say twice. And the fourth one is not closed and is not simple. So a polygon is a simple closed plane figure consisting only of line segments called edges, such that no consecutive edges lie on the same line. We call an endpoint of an edge a vertex, and a polygon is regular if all of its edges have the same length and all of its angles have the same measure. So let's see the figure. Okay, the first figure, figure A or A1 is not closed. Figure A2 is not simple and not closed. A3, this is not a polygon because it is not made of line segment. This looks more like an ellipse. So that figure is closed, but it's not made of line segments. Then B, we have two examples of non-regular polygons. So the angles and sides are not equal. And the last two are regular polygons. The sides are the same length and angles have the same measure. So with that, I'm going to copy the definition. Well, I'm just going to read it. The perimeter of a polygon is the sum of the lengths of the sides of a polygon, and the area is a measure of the amount of surface that the polygon covers. So we measure the perimeter of a figure with the same unit of measurement as we measure the sides, and we measure the area of the figure in square units. For example, we see in this figure here, the perimeter is going to be 6 plus 4 plus 6 plus 4. So the perimeter of that rectangle is 20 feet. And we measure the area in square units. So to find the area, we cut that rectangle into squares of dimensions 1 by 1. So each square has length, well, or the side of each square is 1 foot. So each little square represents 1 square feet, and when we count the squares, we have a total of 24 square feet. So that's a basic formula that I'm sure you have seen before. The area and the perimeter of a rectangle. Okay, so if a rectangle has length L and width W, so let's say we have a rectangle with a given length and width. then the perimeter of a rectangle is length plus width plus length plus width, or 2 times the length plus 2 times the width. And the area is length times width. We obtain this formula by cutting this rectangle into little rectangles of or little squares with dimension 1, and by counting the squares, we're going to have that the area is going to be the product of the length times the width. So from this formula, we can derive other formulas. Okay, so knowing how to do a calculation for one type of geometric figure often leads us to a method for doing the same computation for another type of figure. For example, once we know the formula for the area of a rectangle, we can easily derive the formula for the area of a parallelogram. Okay, so for the area of a parallelogram, so a parallelogram is going to be something like this. It's going to be a figure such that the opposite sides and angles are equal. So let's say this parallelogram has a given length, or let's say a given base and a given height. Okay, so this parallelogram has a given length and a given height. So if we want to find a formula for the area, what we can do is make a rectangle. Make a rectangle with the same dimensions. So at the end, we have a rectangle with a given base and a given height. And really just take this little rectangle and put this little rectangle on the left, just move it to the right, and the area is going to be the same. So the area of the parallelogram is going to be base times height. So I'm going to copy the formula. The area of a parallelogram with height h and base b is h times b, is height times base, or base times height. And a consequence of the formula for the area of a parallelogram is another formula that I'm sure you have seen before, the area of a triangle. So from the area of a from the formula for the area of a parallelogram, we can derive the formula for the area of a triangle. Let's suppose we have a triangle. With a given base and a given height. Okay, so we can place above that a triangle with the same dimensions. So we put the same triangle, but upside down, and we have constructed a parallelogram. So the area of the triangle is going to be, so the area of the parallelogram is going to be height times base, or base times height. But we're looking for the area of a triangle. So the area of the triangle is going to be one half times base times height. So that's a formula that I'm sure you have seen, but I'm going to copy it anyway. You can derive this from the formula for the area of a parallelogram. And a triangle with height h and base b has area 1/2 times height times base or base times height. That's also on page 270 or 470. So we're going to go over example 1. So same page, I'm going to copy this example. And I will copy the figure. Okay, so the figure below shows a recreation area in the shape of a parallelogram. If a pound of grass seed covers 100 square yards, how much grass seed is needed to seed the entire area? Okay, so we're going to find the area of a parallelogram. So in part A, if we look at the parallelogram, the base is 200 and the height is 70. Well, sorry, the height is 150. Okay, so the area of the parallelogram is going to be 200 times 150. And that is 30,000 square yards. Now it says that a pound of grass seed covers 100 square yards. Okay, so to find how much grass seed is needed, we're going to divide 30,000 square yards by 100 square yards. So that is going to be 300. And the conclusion is that a total of 300 pounds of grass are needed to seed the entire area. A total of 300 pounds of grass seed are needed to seed the entire area. That's part A. Part B, suppose that we want to seed only the triangular area ACD, that is this shaded triangle. How much grass seed will be needed then? So we have a triangle with base 70 and height 150. So we're going to do the same. We are going to find the area of a triangle, and we're going to divide it by 100 to find the number of pounds of grass seed. The area of this triangle is 1/2 times 70 times 150. So that is equal to 5,250 square yards. So if we want to know, we want to find the amount of grass seed, we need to divide this by 100. Okay, so let's divide this by 100. That's going to be 52 and a half. And a total of 52 and a half pounds of grass seed are needed to seed the triangular area. Uh, okay. Okay, so that's it. That's regarding the area of a parallelogram and the area of a triangle. But here's the thing. Sometimes we don't know the height of a triangle. So more often than not, we don't know the height, but we know the sides. We know the length of the sides. In this case, we can use Heron's formula to find the area of the triangle. Because the formula is not as intuitively clear as the formula we developed earlier, base times height, or 1/2 times base times height, we will state it without proof. Okay, suppose that a triangle has sides A, B, and C. We define the quantity S equals 1/2 times A plus B plus C. And the area of the triangle is going to be the square root of S times S minus A times S minus B times S minus C. So I'm going to copy the following problem on page 479, number 22. We're going to use Heron's formula to find the area of each triangle. And the triangle, I'm doing number 22. Okay, so let's call the sides. If you want, you don't need to give names to the sides. We can see that S is 1/2 times the length of the side. So that's 9 plus 11 plus 14. 9 plus 11 plus 14 is 34. So S is 17. And the area of the rectangle is going to be 17 times 17 minus 9 times 17 minus 11 times 17 minus 14. This is the square root of 17 times 8 times 6 times 3. 17 times 8 times 6 times 3 is going to be 2,448. And at the end, the area is going to be approximately 49.477 feet, square feet. Okay, so we can use everything we learned to derive the formula for the area of a trapezoid. Okay, so we can use the formula for a triangle to develop area formulas for other figures, such as the trapezoid shown in the figure below. Okay, so that's the next formula, the area of a trapezoid. Okay, let's suppose we have a trapezoid. The trapezoid has a given height. It has an lower base B1 and an upper base B2. Okay, so we're going to do this. We're going to split this trapezoid into two triangles. We're going to cut it. And the height of the triangle above is also h. So we have the height of the lower triangle and the height of the upper triangle. If you add the areas of the triangles, you obtain the area of the trapezoid. So the area of the lower triangle is going to be 1/2 times lower base times height. And the area of the upper triangle is going to be 1/2 times upper base times height. You can factor 1/2 times height, and the rest is going to be lower base plus upper base. So I'm going to copy the formal statement. And remember, multiplication is commutative. So I'm changing the order, or the book is changed. Well, I changed the order to what the book does, but multiplication is commutative. So a trapezoid with lower base B1 and upper base B2, and height h, has area 1/2 times lower base plus upper base times height. We're going to use the formula to find the area of the following trapezoid. Okay, so this is page 473. So the height is 3, the lower base is 8, and the upper base is 4 feet. So the area is 1/2 times lower base plus upper base times 3. Remember, the area is always in square units. The perimeter in the same units, and the area is always in square units. So that is 1/2. 8 times 4 is 12. And you know that 12 over 2 is 6. So the area is 18 square feet. Okay, back to triangles. I did one example with a right triangle. The first example we did involved a right triangle where two sides are parallel. So the height happens to be one of the sides. And the Pythagorean theorem involves right triangles. So in the 6th century, the Greek mathematician Pythagoras proved one of the most famous theorems in the history of mathematics. The Pythagorean theorem states that the sum of the squares of the length of the legs of a right triangle equals the square of the length of the hypotenuse. So I'm going to copy that. Let's copy the formula. And here's the picture that I didn't copy. Let's say we have a right triangle. So if A and B are the legs of a right triangle, so A and B are the legs, and the hypotenuse is C. The hypotenuse is the longest side. Then the sum of the squares of the legs equals the square of the hypotenuse. So we're doing example 4. Okay, use the lengths of the two sides to find the length of the third side in the triangles in figure 941, in the figure below. So in the first triangle, we know the lengths of the legs. So remember, units are important. The units are in inches. So the hypotenuse is going to be, or the square of the hypotenuse will be the sum of the squares of the legs. So A squared is 64. 6 squared is 36. And 64 plus 36 is 100. So if C squared is 100, C is going to be 10. And that's going to be 10 inches. And in B, in part B, we know the hypotenuse and the length of one of the legs. Okay, so A is 15 meters. And the hypotenuse is 16 meters. We need to find the other leg. So the Pythagorean theorem says that 15 squared plus B squared equals 16 squared. 15 squared is 225. And 16 squared is 256. So subtract 225 from both sides. And B squared is 31. So the exact value of B is the square root of 31. But for in practice, we'll need to approximate the length of the side. So B is approximately 5.57 meters. And the last figure is going to be a circle. As with polygons, we often need to calculate the circumference and area of circles. The derivation of these formulas is not as intuitive as those for the polygons we have been discussing. So we will state them without proof. The number pi, which appears in this formula, is the Greek letter pi. And that's an example of an irrational number. You remember irrational numbers are those that cannot be written as the ratio of two integers. And it stands for the measure of the circumference of a circle divided by the length of its diameter. So the number pi is approximately 3.14. Or in this book, we're going to let it be 3.14. That's just an approximation, but the truth is that it has infinitely many decimals, and it has no repeating pattern. So that's an irrational number. So another formula that I'm sure you have seen before is the circumference and the area of a circle. Let's say we have a circle with radius r. So the radius is going to be the distance from the center to any of the sides. So a circle with radius r has circumference 2 pi times r, or pi times diameter, and area pi times the square of the radius. So I'm going to finish this section with number 37 on page 480. Okay, so I'm actually going to read first the part of the problem, and then I'm going to copy the problem. So in the area of Pennsylvania where the author lives, many Pennsylvania Dutch barns are decorated with hex signs like the one shown below. Some signs are intended to bring good luck and others to ward off evil. So let's do number 37. Jacob has created hex sign A that has a circumference of 150.72 inches. Hex sign B has a circumference that is 1.2 times that of sign A. What is the area of sign B? So we have two signs. We have sign A that has a circumference of 150.72 inches. And hex sign B has a circumference that's a little bit larger, so the circle is going to be a little bit bigger. We know that the circumference of this one is 150.72. So the circumference of the second one is going to be 1.2 times 150.72. So 1.2, so that's going to be 180.864 inches. We want to find the area. And in order to find the area, we need to know the radius. As long as we know the radius, we can find the area. Okay, so this is what we know. We know that 2 pi r is equal to 180 0.864. So this is for sine B. So pi is approximately 2.31 or 3.14. So 2 times 3.14 is 6.28. And the radius is going to be 180.864 over 6.28. So the radius is what? The radius is 28.8. And the area of sine B is pi times the square of the radius. So that's pi r squared, where pi is approximately 3.14, and the radius is 28.8. Let's calculate that. So 3.14 times 28.8 squared is, okay, let's see. Okay, I took the square root. So that's 28.8 squared. Yeah, times 3.14. Okay, there it is. Yeah, I think I didn't hit equal. Yeah, but that's 2,604.4416 square inches. Okay, so this is it. This was the first section on perimeter and area. Thank you for listening.